Now we are discussing about the first, second and third derivatives of the following function. How to find the first derivatives, second derivatives and third derivatives of the following functions. The functions which I am taking over here is y is equal to sin x. I am taking a very simple function just to understand how to take the derivatives. Sin x plus cos x. When we take the first derivative, then what we will write? We will write actually just like as differentiate with respect to x on both sides. Differentiate with respect to x. With respect to x. When we take the differentiation with respect to x, then it will be y prime. The first derivative is actually represented by y prime. The derivative of sin x, it is cos x, and the derivative of cos x is minus sin x, and plus minus will be minus, so we will write over here sin x. This is the first derivative of the given function. Now we want to take another derivative. We will again write differentiate again with respect to x. Again, and after writing differentiating again with respect to x, then we will write y double prime. So y double prime means that we are taking the second derivative. The second derivative of cos x, it is actually minus sin x, and the derivative of sin x is it is cos x. Remember that now we are taking the derivative of the above equation, this one equation. It's okay. So this is the second derivative which is represented by y double prime. So we want to take now the third derivative. When we will take the third derivative, we will again write differentiating again with respect to x. When we differentiate, the third derivative will be represented by y triple prime. Okay, and this will be equal to the derivative of minus sin x is minus cos x. And we know that the derivative of cos x, this is cos x, it will be minus sin x, minus and minus, this minus will be plus, it will be equal to sin x. So this is the third derivative. Remember that this is the third derivative of the given functions. We are taking another example. In this example, I am writing just like as y is equal to just like x4. I am taking a very simple example. So when we will take the first derivative, we will write differentiate with respect to x. When we will differentiate with respect to x, then it will be just like as y prime is equal to the derivative of x4 is actually 4x cube. In the similar way, again differentiate with respect to x. Then we'll take again differentiate with respect to x, then it will be y double prime. This will be represented by y double prime, and the derivative of 4x cube, it is actually 12x square. Since we want to find the third derivative also, so we'll again differentiate with respect to x. Differentiate with respect to x again. Okay, so this will be represented by just like as y triple prime, and this will be equal to the derivative of 12x square is 24x. If I will take another example, just like I am writing over here, y is equal to, okay, here we will find the fourth derivative. Y is equal to just like I am writing over here sine sine x only. Okay, so if I write sine x, the first derivative will be y prime is equal to cos x, and the second derivative will be y double prime, the derivative of cos x, this will be equal to minus sine x, and the third derivative, which is y triple prime, will be equal to minus cos x. And if we want to find another derivative, which is y fourth derivative, it will be represented just like as this will be equal to minus the derivative of cos x is minus sine x, so minus minus will be plus, so this will be sine x. So this is the way how to find the first, second and third derivative, and as well fourth derivative of the given functions. And if we want to find the derivative fifth, second and up to so on any derivative, then we use the Leibniz rule, but here we are discussing only the first, second and third derivative. Hope you have understand. If you have any questions related to these examples, then you can ask the question in question answer sections. Hope you will do the question. Thank you very much.